This is a giant mirror floating in orbit above the Earth that might seem too weird to be true, but I can assure you that this is indeed very real footage showing one of the most interesting man-made objects to ever be launched into space twice. And it's not only the giant mirror that makes this story interesting, it's the not-so-secret Russian plan behind the space reflector and what happened after they deployed this contraption. There are actually several potential use cases for a giant reflector. In outer space, and this is not a new concept by any means, these go way back, there is a legend that the ancient Greek scientist Archimedes designed great burning mirrors that set fire to the Roman fleet as they lay siege to his home city of Sicusa, Italy. Archimedes died in that battle, so the legend is probably not true, but it does sound like a pretty badass way to go down. In 1929, a German physicist named Hermann Oberth developed plans for an orbital space station that is equipped with a concave mirror measuring 100 m across that could be used to reflect sunlight onto a concentrated point on the Earth. We know where this is going. During World War II, that orbital mirror idea gets picked up by Nazi scientists and developed into a conceptual super weapon, the Sun Gun. The updated plan would be to deploy a giant space station 88,200 kilometers above the surface of the Earth. It would wield a huge reflector made from metallic sodium that would cover a surface area 9 square kilometers. The Sun Gun would produce enough focused heat to incinerate an entire city or boil away the water in lakes and rivers, or at least that's what Nazi scientists claimed they were working on when taken captive by American soldiers near the end of the war. There was an article published in the July 1945 issue of Life magazine that illustrates the whole plan. It's pretty fascinating. But even the magazine writers of the 1940s were able to point out the fact that even if the Germans could place a gigantic mirror into space, thousands of miles from the Earth, it would not create a death ray. The concentrated heating effect from reflecting sunlight only works at short focal distances, like when you use a magnifying glass to roast an ant. But when you try to do the same thing from space, you just end up projecting a giant circle of light onto the Earth's surface. It wouldn't be hot enough to do any damage. So that's good news. There's one less thing to worry about. But if you can't turn a space mirror to create a giant death ray, then what do you use it for? This is the father of the modern space mirror, Vladimir Kyotnikov, a Russian engineer born in 1933. He grew up in a turbulent world under the control of Joseph Stalin, an era of violence, political purges, and the obsessive militarization of the Soviet Union. The only real positive to come from this era was a flourishing community of Soviet scientists and engineers who were put to task developing the nation's arsenal of nuclear weapons and fleet of space exploring rockets. Vladimir thrived in the space race. He helped design and develop Voso, the world's first crewed spacecraft, which would launch Yuri Gagarin into space in 1961. By the 1970s, he's climbed the ranks to the top of the Soviet space program and is designing advanced spacecraft docking systems, including the androgynous peripheral attach system, which would link the Soviet and American space capsules in the Apollo So test flight, the first international cooperative space mission. His updated design of that system would later be used on the Russian space station Mir and allow for docking with the American space shuttle. Behind all of his important work for the space program, Vladimir had a personal fascination with solar sails. The idea is that a large reflector can be used as a method of spacecraft propulsion, capturing radiation pressure from sunlight to travel deep into the solar system without having to burn any fuel. The Soviet leadership wasn't quite as impressed with the idea. Heading into the 1990s, the space race was over, and the USSR in the midst of a total collapse. If government money was going to be spent on funding an engineering project, then it would need to demonstrate some kind of an economic advantage. So Vladimir rebrands his solar sail into a new idea that will revolutionize economic productivity in northern Russia and beyond. The thing about the northernmost regions of the world, those places near or above the Arctic Circle, is that they experience a very unusual day and night cycle thanks to the tilt of the Earth's axis. In the peak of the summer months, the sun never really sets, but on the flip side, in the dead of winter, the sun never really rises. That extended period of winter darkness makes it pretty near impossible to get much done, and it requires a large amount of energy to keep the lights on and the heaters running. Not that there are a whole lot of human beings living at these high northern latitudes, but a significant portion of the Arctic landmass does belong to Russia, and there are many Russians who live and work up there. So Vladimir gets an idea. Instead of using a giant reflector in space as a sail, It could be used as a reflector. It could then redirect light from the sun in space down to a town in northern Russia living in extended darkness. Just imagine the increase in economic productivity that these northern regions would experience if a space mirror could be used to simply turn the sun back on. Not only that, it would drastically reduce the cost of electric lighting and fuel for heating, and thinking even bigger, a whole chain of these reflective satellites could be placed into a sun-synchronous orbit, so that they all remain in a constant position above Russia, and they could all just beam down sunlight 24/7. It would be daylight all night long. Now, not surprisingly, this perpetual economy machine was a lot more well-received than the deep space exploration thing. Vladimir didn't really need the support of the government anymore. Private investors were pouring money into the giant space mirror project that would come to be known as Zia. It translates to banner in Russian. The first prototype was built as a ground test model. It wasn't sent to space. It was just an exercise to perfect the design for Namia 2. The plan was to gradually build up the size of their space mirror designs. Kamia 2 would be 20 m across, followed by version 2.5 at 25 m, then V3 at 70 m. This would culminate with a permanent Zamia installation reaching 200 m in diameter. There would be somewhere between 24 and 36 of these giant mirrors traveling in a northern inclination orbit. The altitude would be set as low as 1,000 kilometers or as high as 6,000 kilometers. Each reflector could light one area on its own, or multiple could be focused on the same area for greater brightness. It was believed that the full-size Zamia would produce light 50 times brighter than the full moon and illuminate a surface area between 60 and 90 kilometers across. On October 27, 1992, the first ever space mirror was launched on board a Progress spacecraft from the Mysore Cosmodrome. The autonomous spacecraft would then dock with the Mir station, where crew members would fit a 40 kilograms drum containing the folded reflector into the docking port of Progress, which would then depart at the station and move to a position about 150 m away. An electric motor inside the drum begins to spin and unfold the 8-segment reflector disc. The circular shape is maintained by the rotation of the drum, and the position is controlled by the maneuvering thrusters on Progress. On the morning of February 4, 1993, Kamia 2 would produce a 5 kilometers wide beam of light that traveled over the surface of the Earth from southern France to western Russia. The bright circle traveled at an estimated speed of 8 kilometers per second and had the brightness equivalent to a full moon, so anyone witnessing this from the ground would have seen something more like a quick flash than a giant beam of light, and hardly anyone even saw the flash because much of Europe was covered by thick clouds. That morning, the mirror was deorbited after several hours and burned up in the atmosphere over Canada. It was far from the most impressive technical demonstration, but Zamia 2 was only ever supposed to be the first stepping stone in a long line of Russian space mirrors. It would ultimately take until 1999 for Namia 2.5 to be ready, but it did fly to space on February 5 with a 25 m diameter reflector that would have been capable of projecting a 7 kilometers wide bright spot onto the Earth with a brightness equivalent of between 5 and 10 full moons. The objective for this demonstration would be to keep the spotlight on a fixed position for several minutes at a time. Unfortunately, soon after deployment, in the process of unfolding the mirror, the ultra-thin Meyer film got stuck on an antenna of the Progress spacecraft and caused a rip in the material. Operators on the ground tried to free the snagged mirror, but Kamia 2.5 was declared a failure, and the whole thing fell helplessly back to the Earth and incinerated. That one catastrophic failure was enough to kill the entire Zamia project. Version 3 was never built, and a deer died a few years later in 2006. In the time since, the people of Earth have never again launched a giant mirror into space, probably because it's just not actually a particularly useful thing to have. It can't be used as a death ray, and it's highly questionable to think that there would be any substantial benefit to any living thing from having perpetual sunlight. You'd almost certainly cause more harm than good, but the 90s was a wild time. You could get away with some weird stuff like launching not one, but put 2 giant mirrors into space just to see what would happen. So here's to Vladimir. I'm so happy that your idea didn't work, but I deeply respect you for trying.